To start with the architecture, let's understand what is region. Okay, so the first part itself says that the table is made of regions. So what does this mean? So if you see this architecture here, okay, components, these are nothing but the table regions. So this is your actual table which holds the data. So sometimes people may confuse you saying that what is the difference between table and region. Region contains table, so each region will contain only one table. Table is made up of regions. A region, a range of rows stored together. Region, a table is made up of regions. Okay, regions are nothing but a range of rows stored together. So in a table, if I say we have numbers of records, right? So all those records are called regions. So it is like put together. So singles are used for scaling. Okay, so now it's coming the sorting that you had asked yesterday. Dynamically split as they become too big and merged it too small. So what does this mean? Sorting. The definition of sorting is this one. So now you understand what is sorting. So sorting is nothing but the dynamically splitting of the data when they become too big and it cannot be accommodated in a single thing. In a single block. People don't means the users do not break it manually. It is an automatic process handled by HBase. Whenever it is like a very big file, so it will start breaking up into the chunks, which will be and the size of the each chunk will be same to the data, same to the block size, so that it can fit inside. So now what is region server? Region server is something which handles or manages regions, more than one region. Okay, one or more regions. The region is served by only one region server. One region will only be served by one region server, but one region server can serve more than one region. If someone says like what is table made up of, then table is made up of regions, which is nothing but a logical split. What are regions? Regions are nothing but a set of rows, records stored together. So under this section, whenever like definitely as we have seen this table, this is just a two row, okay, row 1 and row 2. So what happens? Let's say we had millions of records. Definitely each of the records, whenever we do some kind of transactions on that, we will have different timestamps, which is nothing but the version of the same data. Slowly it will become big. So when it becomes big, the sharding starts happening. So sharding occurs. Sharding means whenever this file is big enough that cannot be accommodated in a single block unit, so it will start splitting it from some row levels. So it will split and it will get saved into some different block or on maybe in a different node even. The region server. So region server is nothing but a like a manager for one or more than one region. Okay. So one region will be managed only by one region server, but a region server can manage more than one region. Then it is master server, a daemon responsible for managing HBase cluster, AK and region servers. AK is nothing but the acknowledgements. HBase stores its data into HDFS. Definitely it relies on the HDFS storage. On Hadoop architecture, we have slave nodes, we have master nodes. So what is the purpose of master node in Hadoop structure? In Hadoop master node, the main funda of master node is nothing but the storage of the metadata information of the entire cluster, which job is running where and which data is stored where across. Okay, and it also has a job tracker which is responsible for managing all the jobs running in the different data nodes. Okay, so task tracker, what I can say, task tracker gives information to the job tracker, means task tracker reports to job tracker, okay, for the job scheduling and job running, job execution. And data nodes report master node for their metadata information. because everything is about the complete structure of the cluster. The metadata information about complete structure will be stored in master data and inside in RAM. That is why for master nodes, the amount, the RAM size should be very high. Means the RAM should be very good in capacity, because it contains everything in RAM in master node. Similar thing happens here in here. So if you see this architecture, see this. So this is a master server which is nothing but managing the region servers, and region servers are managing the regions, and this regions are managed by Zookeeper, which is nothing. If you remove Zookeeper, it will be managed by region servers only. But when you implement Zookeeper, what is the purpose of Zookeeper? It provides a coordination between the complete regions and the region server and the master. So it manages everything. So it is just like a management service. So master is again communicating directly with the region server just to get the metadata information about the region. But the task and the table configuration and everything will be managed by region servers. And definitely it sits on the HDFS. Okay, and we have H file and WL, which you'll see in the next slide. What does this two file mean? These two things mean, H file and WL. Okay. Getting it?
Yeah.
So HBase utilizes Zookeeper for distributed coordinations. HBase is utilizes Zookeeper for distributed coordination that I have already told in this one. So in the next picture, see this one. Rows distribution between the region servers. Think of this thing. Now this is a block diagram actually. Okay, you have a block of 3 region servers. Inside that you have different regions, and these are the rows. So logical view, all rows in a table. So these are the rows: A1, A2, A22, A3, A4, 090, Z30 and Z55. These are nothing but the rows. Okay, and see how these are distributed. So this is a block of like rows. This is a block of rows. This is a block of rows, and this like 1, 2, 3, 4, 5. We have total 5 block of rows. Altogether, it is a single table. For the first thing, the region server is here. For the first block is written into a region. We know that region is nothing but a collection of records. Okay, this is a region null till A3, and then second block from A3. Sorry, it should be A22. Okay, and then it is like from A3 to F34 something, and then it is again going with the F34 to K80, and then K80 to 095, and then again the last region is 095 to null. Means you can see the block of rows, which is known as region, is randomly distributed across the region server. Region server are nothing but a server, a coordination system which manages the different regions for a single table. So HBase region. What are regions? Region is a range of keys that we know. Okay, range of keys means the records. So start key, stop key. So start key and the stop key we will be having. Example K3COD and okay. So this is just a random number that is used. Okay. So start key is inclusive and stop key is always exclusive. So this is one important thing, like the range of keys that in a region. What is the inclusive and exclusive? So start key is always inclusive and stop key is always exclusive. Addition of data. How can we add? So at first there is only one region. Addition of the data is will eventually exceed the configured maximum. The region is split. So default is 256 MB. Region will get splitted if it is exceeding 256 MB in the size. So like in this picture, this region will accommodate up to 256 MB of data. When 256 MB of data is complete, it will start splitting the data to a different region, maybe in a different region server or in the same region server. The region is split into two regions at the middle key. So again, when the data size is more than 256, let's say 300 MB is the total size of the data, then the second point, what does it say? The region is split into two regions at the middle key, means that if the data block size is 300, it will split 150 and 150. It will not split 256 and 44. Okay, it will split 150 and 150. The example is here. See, region per server depends on the hardware specs. With today's hardware, it is most common to have 10 to 1000 regions per region server, managing as much as 1 to 2 GB per region. So I think you got your answer in this one. Okay. So how the splitting happens? That whenever it exceeds more than the default size, okay, or we can say the allocated size, it will split into different regions with a middle key. Okay, and based on the region split happens based on the hardware specifications particularly, and we can have 10 to 1000 regions per region server and managing up to 1 to 2 GB per region. So one region can contain up to 2 GB data. Then splitting of the data into region allows fast recovery when a region fails. Why we need splitting? So for the fast recovery, then it helps in load balancing. Splitting is fast reads from an original file while asynchronous process perform a split. All of these happen automatically without user involvement. The user just need to give the block size, like the default size, 256 MB, and it can be like configured to 128 or 256 or 512, so anything. So now coming to the data storage, obviously since it resides on HDFS cluster, the data is stored in HDFS. Okay, but the file that is used, we saw in the previous slide that it is called as H file / store file. So H file is nothing but a key value mapping. Okay, keys are sorted lexicographically, and then when data is added, it's written to a log called write ahead log. This is your write ahead log, and it's also stored in memory, memstore. This memstore is nothing but the RAM. Flush. When in memory data exceeds maximum value, it is flushed to a H file. So how the H file stores the data? So first it is written into memstore. Okay, and for particular this write operation, there is a WAL file getting generated. If the memory exceeds, means the data what is being written is more than the memstore available, it calls the flush operation, and flush will create a H file which will hold the remaining data. So data persisted to H file can then be removed from WAL. So any data what was written in H file, okay, can be removed from WAL. Means the log file can be cleared. Region servers continue serving read-write operation during the flush operations, writing values to a WAL and memstore. The region server manages all this read and write operation even when there is a flush operation happens. Usually most of the databases will stop writing log. Okay, the data, when data is added, it's written to a log called write ahead log. So it is actually not storing the data, it's storing the log information, like this particular set of data has been written into this memory location, mem store. Okay, and when the mem store, that is the memory, is insufficient of storing the complete data, then it creates a H file. Okay, so H file is a permanent file. Okay, it's a persistent, like it's a permanent file written into the file structure. When region servers understand that the data is already written into H file, those particular section of writing is removed from the log. Means WL doesn't contain any information about the H file storage. So it will just say like, you want this data that is there in the H file. So go and get it from there. So if there is no H file generated, everything will be written in mem store. And for that particular retrieval, read and write operation, if I want to access some particular data, this WL, this log will help me in finding out where the data is actually. See, the write ahead log records all changes to data in HBase to file-based storage. To file-based storage, under normal operation, the wall is not needed because the data changes move from the mem store to the stored files, the H file. Okay. However, if a region server crashes or become unavailable before the mem store is flushed, the wall ensures that the changes to the data can be replayed. If writing to a WL fails, the entire operation to modify the data fails. Now, it is clear why WL is used. So it is nothing but a log which maintains the information about the data stored in mem store. If mem store is not sufficient of storing the data, it creates a H file, which is nothing but a file, normal file in a file system, which is read and understood by HBase internally. So if you open any HBase file, it will have arbitrary symbols, which is not understandable by simply it's not text. So then the data storage. Recall the HDFS doesn't support updates to the existing file. Therefore, H files are immutable. So since HDFS, what happens whenever you want to update a particular file, it will not update it. It will create a new file. So any file created in HBase or HDFS is immutable. It is not mutable. Okay, cannot remove key values out of H files. Over time, more and more H files are created. Means as the time passes or as we keep on doing the operations, the new files will getting generated. So once a time will come when your complete memory is used. So how to manage this? We'll see this in the down slide. Okay. So it's not a good practice, right? Whenever you create whenever you create some updates command or you want to update the database, what is happening here? It will not delete the data. It will not update the data. It will create a new file. That is how versioning of the records. When you do a delete operation, what happens? Delete marker is saved to indicate that the record was removed. Okay. These markers are used to filter the data to hide the deleted records. So at runtime, data is merged between the content of the H file and WAL. It is a common thing everywhere. Every NoSQL is working on the same funda. So since I know Vertica, in Vertica also same thing happens. Whenever you delete a file, it doesn't get deleted directly from the storage. So it is marked as deleted, and we have to manually purge it. So same thing happens in HBase as well. So whenever you delete it, the particular record is marked as deleted. So it has a marker now which says that this has been deleted, so hide it. Do not let people access it. So data storage. The next is to control the number of H files and keep clusters well balanced. HBase periodically performs data compaction. So this is how your newly updated files and the old files are managed. So basically we have two compaction, major and the minor compaction. In minor compaction, what happens? Small H files are merged into a larger H file. Okay, n-way merge, we call it as the n-way merge. So past data is already sorted within the file. Delete markers are not applied. So here in this particular case, what happens when you do a minor compaction, it merges all the small files. So there is no delete marker applied over the file. But in major compaction, what happens? For each region, merges all the files within a column family into a single file, scan all the entries and apply the delete as necessary. Got it? So in this one, major compaction, what will happen? All the files within a column family are merged into a single file, and the old file HBase Master. So till now we saw how the data is stored and how the data is managed in a HBase. We know out of this storage, the important question is this one: what is H file and WL, and how the delete operation works in HBase. Okay. So coming to HBase Master, we know like HBase Master is responsible for managing all the region servers. Region servers are responsible for managing all the regions, and regions are nothing but a set of records, and regions constitutes a table. Means region, combination of regions makes a table, right? So now let's see what is HBase Master. So responsible for managing regions and their locations, assigns regions to region server, rebalance to accommodate workloads, recovers if a region server becomes unavailable, uses Zookeeper for distributed coordination services. So these are the main responsibilities for a region server, for a HBase Master, and it manages these particular operations. Okay, next is it doesn't actually store or read data. So just like master node in HDFS, it doesn't do any storing or reading of the data. It is just a way to manage. Okay, so the same thing happens there also, right? Clients communicate with the master node, and then master node gives the information about the actual data, actual operation to the client, and then client communicates directly to the data node. So same thing happens here. So client communicate directly with the region server. Once it is communicated with the H-Master, then client directly communicates with the region server instead of HBase Master. Usually lightly loaded, so it is not heavily loaded. But again, the configuration of these HBase Master are required as a very good configuration, because it's the same concept. Everything is stored in a RAM. So the configuration, total processing, and the RAM capacity should be more. Responsible for schema management and changes, adding, removing tables and column families. These are managed by HBase Master. So what is HBase and Zookeeper? How HBase and Zookeeper are interrelated? So HBase is a Zookeeper extensively for region assignment. So Zookeeper is a centralized service for maintaining configuration information, naming, providing distributed synchronization, and providing group services. Okay.
Is the job of Zookeeper just region management?
Sorry?
I mean, what exactly is the job of Zookeeper? Is it just region management?
Yeah, correct. It is just a region management. So let's say all of a sudden when a region goes down, okay, because of performance, because of some issue, not the power failure or not the hardware failure, it's a normal failure happens. So region server will be there to recover that automatically.
Then, I mean, so this is also the region master, right? The region master and Zookeeper are the same. Is that right?
I didn't get region master, right?
and the Zookeeper, are they one and the same?
And 1 second, I'm not getting you. Use the headphone. Yeah, please say again.
Yeah. So the Zookeeper and Region Master, are they one and the same?
No, they are not the same thing. They are different. Zookeeper is a third-party tool. Okay. And region servers and HMasters are the HBase components. Yeah, it is used. So I'm just saying that when you do not have region Zookeeper, region servers are there to manage it. But region servers are not so effective or not so good in terms of managing the servers, managing the regions. Okay, that is why Zookeeper is being used, because Zookeeper manages not only the regions, it manages everything in Hadoop. Not only HBase. You can use Zookeeper for managing the Hadoop cluster itself. Okay, so it checks whether a node is down, it checks whether the region is down, it checks whether the region server is working or not, it checks whether the proper metadata exchange is happening, it checks whether the load balancing is there or not. So everything is managed, coordinated. It just coordinates the services. Okay, I think I have a clear diagram of this on this. See, when I come to this diagram, you will see this. Okay, so HBase can manage Zookeeper daemons for you, and you can install, manage them separately. So that is what I can say, told you, right? So HBase can manage Zookeeper daemons, so which you can install or manage them separately. So it is not a HBase component; it's a separate third-party component which is used for the coordination, proper coordination. So next, in this section, what we have, Zookeeper crash course. So very simple, feel like API written in Java. What is Zookeeper? So it's a simple API written in Java. Operations on directories and files called Z nodes. Okay. CRUD Z nodes and register for updates. Support persistent and ephemeral Z nodes. I forgot what is ephemeral Z nodes. Sorry. Let me check this. So the region server will first close all the regions and then shut it down. On shutdown, the region server's operational node in Zookeeper will expire. So the master will notice the region server gone and will treat it as a crashed server. So it will rescan the nodes the region server was carrying. Okay. So it says it is nothing but the internal management of the nodes by Zookeeper. So whenever the Z nodes are nothing but the Zookeeper nodes. So Zookeeper takes every node as its own nodes, Z nodes, which are responsible for HBase operations. That is why it is supports persistent and the ephemeral nodes. Okay, so persistent means which is as a physical node available, and this node means the virtual node that was in memory of Zookeeper. So whenever there is a node failure or something went wrong, so it will be removed from the Zookeeper memory. As you can see here, it is this thing, right? The master will notice the region server gone and will treat it as a crashed server. So it will say like that particular region server is not existing, so reassign the nodes that was there with this region server. Okay, clients connect with the session to a Zookeeper. Session is maintained by via heartbeat. If client fails to report, then the session is expired and all the ephemeral nodes are deleted. So whenever there is a client interaction, it creates the ephemeral nodes. Okay, client listening for updates will be notified of the deleted nodes as well as the new nodes. Then see this one. So each region server creates an ephemeral node. Master monitors these nodes to discover available region servers. Then master also tracks these nodes for server failures. So why each region server creates ephemeral nodes? Because master monitors these nodes to discover which node is available or not. So once it is available, it assigns the nodes to those particular region server, and if it is not available, it will reassign those nodes to the available region server. Uses Zookeeper to make sure that only one master is registered. So again, master server is like it should be only one, like the master data node in Hadoop 1.2.1. What happens? Master node is only one PC. Okay, but in Hadoop 2.0 there is no single one master node. It is like many master nodes managing their own metadata information, but at a particular point of time only one master node is up. Okay, so similar thing happens here. The Zookeeper is there to manage to see like only one master node is only one master server is registered in the cluster. Okay, for single cluster one master should be there, but many region servers can be there. You can see here that CRUD gen nodes register for updates. So support for persistent and ephemeral. Okay, ephemeral gen nodes. So persistent is nothing but a permanent Z nodes, and ephemeral is nothing but a temporary Z nodes, means the nodes. Clear? So HBase cannot exist without Zookeeper. So this line is applicable for the newer version of HBase. Okay, earlier it was not like that, but in the latest version of the Zookeeper, it is inbuilt. You need not to install it separately. So it is like inbuilt, the newer version. Okay, so this is the components. We have master, we have Zookeeper, which is nothing but a coordination services between master and the regions. And the region servers is again for managing the read-write operation and the H files. So region servers are mainly responsible for managing the H file and WL and the regions. Okay, and the H file and WL are the files. H file is the actual file which holds the data, and WL is nothing but log file for write operations. Okay, if you see the deployment of Hadoop, how does it look like in a cluster? You will find out like this is your Zookeeper. Okay, these all are management nodes. So in Hadoop, what we have two management nodes. One is your master node, and second one is a secondary node, right? But in HBase deployment, we have Zookeeper, which is available on all the management nodes. One will be your HBase Master, second will be your HDFS name node, okay, and the third one will be your HDFS secondary name node. Why these are two? These are the Hadoop components, but this is a HBase component. So HBase Master is there, and again, for each of the data nodes that are available in a cluster, Hadoop cluster, it is again HDFS and data node will be there. For each of these data nodes, we will have a region server, and each of these region servers are responsible for managing the regions inside this region server. Okay, so if you say,
Ravi, we might have to talk this tomorrow. Is it okay?
oh, okay, 9:30 is already there. So just one diagram. Okay, so this is your region. This is your region server, and this is your region, and inside that we will have different records. Okay, so this is your records, and this is your region server, and no, this is your actually region, and this is your region server. So it is something like that, contained in a single container with region servers and region and the actual data, the tables. Okay, fine. So we have just how to access this. We have different APIs in place, like Java API and different proxy servers are there, like Apple server, HBQL, and it is like the simplest query language. Okay, and how we can access? We can access by HBase, async HBase, GPA. There are different ways. Okay, so but most of the time people use REST server and the thrift. Okay, to access to work on HBase. So either you can directly use the command line, you can use Java API, or you can use REST server or the thrift server. So these are other ways, but not commonly used. So we will see the command line and the Java API.